and today we learn about strategy design pattern. So before starting this design pattern, let's see why do we need it? What is the problem statement? Okay, let's suppose we are building one functionality where we need a vehicle interface, and this interface is extended by bike class and car class. This vehicle interface has one method called drive. Okay, so now bike class in this drive method we have written functionality how two wheelers are being drove. Okay, so similarly in car drive function we have written about how about four wheelers. Okay, so this is fine till now, but what if there's one more class extending in this interface called scooty. Okay, so in this drive functionality again we have to write functionality how two wheelers are being drive. So now you can see this drive two wheels is same functionality which we have written in bike. Okay, and this is the same code. Now in future if we say like we need to implement another electric scooty or any other class here, and again we have to write the functionality of two wheelers, so we have to again write the same code. And in some day if we need to do any changes in the code, we will have to do code changes everywhere we have written to drive two wheelers functionality, which is a problem and which is not recommended to do, because there should be only single piece of code we can reuse if we want that. To solve this problem, this strategy design pattern came. So what we do in this design pattern, we create a strategy, drive strategy with functionality drive, and we extend it to two wheel strategy and four wheel strategy. And in respective drive functions, we write what we really want to do. Okay, and this strategy class is being used in now different scooty bike class. Okay, so we have this strategy here, and the drive of scooty will call drive of the strategy. So if someday I want to change, now I want like car to be driven also as scooty or two wheelers maybe, so what we have to do, simply come and change the type of this strategy which we have written here, nothing else. So this piece of code is pretty much is extendable if you want in future, and this is a more cleaner way to write any code or solve any problem. I will also show you an example with the code. Let's see what is an example. So for what here I've done is I have one vehicle class, and this vehicle class I have sports car and normal car. Okay, so how sports car are driven can be different, how normal cars are driven can be different. So what I've done is I have created one. I have this uh, drive interface. Okay, which is extended to normal drive and drive fast. And in vehicle class, I have object of this drive. Now in sports car, I will say that this vehicle is my sports car will use fast drive strategy, and normal car will use normal drive strategy. Okay, and if I create objects of normal class and sports class and just call drive, let's see what happens. If we see normal drive and fast drive, normal is for normal car and fast is for fast car. Let's do one thing, change it. Now I want my normal car to be driven as fast car. So what we have to do is just change this. Now my normal car can be also be driven fast. Okay, so let's see what will happen if we run this. Wow, both cars are driven fast. So this is pretty much extendable code which we can use. And what we have done is we have created a constructor wherein we are passing our strategy to parent, and this parent is assigning it to a drive, and then we are using the same drive functionality here. Okay, so you can, I will upload this code in my GitHub repo. You can go and watch this. I will also try to upload the Java part of this. You can also see how we can do this same thing in Java. So yeah, I think that's it for strategy design pattern. I will be coming up with more design patterns and also problems where how we can use these design patterns there. Till then, take care.